Let's start from the beginning. The earth cooled, then dinosaurs were on. Okay. So the point is that she would take me to self-defense demonstrations, and she wouldn't whoop on me, beat me up, and not for real, but I was her punching buddy. And some of the things I learned from her, because I never grew up boxing or anything, she said some of the hardest hits, when it looks like the person got knocked, like just really hard, she's like, those don't hurt the person because the person actually learns to go with the punch. So if you see someone's head fly off, usually it's the person who's getting hit going with the punch to absorb and dissipate some of that force over time. She said the ones that really hurt are the ones that don't look like, right? So where they hit you and they don't go anywhere, that your body absorbs most of that energy. Okay? So it's the same thing where we have parts of the body that don't want to give too much, but have to give a little bit to sway or to dissipate. As we're going to see, they can glide and kind of summate each other's motion. Kind of like a slinky. If you take a slinky and do this, all of that motion didn't take place at one part. It was a little bit here, a little bit there, a little bit, little bit, little bit, little bit, little bit. It's like saving change. When you go to put change, anybody save change? Like have a little change container, right? A few cents here is not a big deal, but over time, it adds up, right? Okay? So places in the body that we have a little bit of motion, more than none, but less than most. Let's look at a few places. Any two vertebrae, I'm not saying all the vertebrae, because that's kind of a sum total thing we're going to talk about in the last category, but any two movable vertebrae, not our fused down here, which, by the way, our fused sacral and coccygeal, that's Synarthrodial, right? Fused up, articulations that don't move. But any two of our vertebrae, there's just a little bit of motion. Nothing significant, but just a little bit of play. And that's there to dissipate force. I mean, we have nerves, and we have vessels, and we have a lot of tubing that runs there. And if it was just stiff, it wouldn't take a lot to snap, but we have to be able to give and dissipate force there. Other areas that we kind of have a little bit of motion are in our metacarpals. Not here, but here. And what that's for is when we grip and grab things, it allows to kind of contour and summate little bits of motion so that we can contour our hand around things and grab. So in other words, unlike our fingers, in between each metacarpal, there's a little bit of play. There's a little bit. It can kind of orbit around whatever object you're trying to grab. And also a place that we have a little bit of motion is right here. This is pretty cool. Our pubic symphysis. Our pelvis allows just a little bit of rotation. So that way when we move our hips independently, our pelvis can kind of dissipate some of that force instead of having a bad day. Okay? Little bits. Now there's two different subclassifications of little bits. And the two different classifications isn't different because of a little bit of motion. It's a little bit of motion because of what? The structures that allow a little bit of motion. So when it's a little bit of motion because of ligamentous articulation between the bones, we call that syndesmotic. So syndesmotic is a subclassification of Amphiarthrodial, if that makes sense. Okay? It's a subclass. Examples of syndesmotic would be here, your metacarpals, an example, ligaments that you have interosseous membranes and ligaments that were moved. And then back here, 82 vertebrae, you have facet joints that are bound together by ligaments, and the small motion in between there is allowed by the ligaments. Okay? The other subclassification is synchondrotic. Synchondrotic, chondro for cartilage. Chondro for cartilage. And what's really cool is that you can find both of these in the vertebra. Synchondrotic would be the front part of the vertebra, the little motion that would be in between the water balloons that are the discs. Synarthrodial would also be here for the pubic symphysis. It's cartilage articulation. Okay? Syndesmotic, synchondritic. Now, this is, let's see, 7:40. This is where things get a little different, but I'm hoping if I do my job and explain it the right way, it shouldn't be all that difficult. How many of you, as a kid, used to play with dominoes like I did? I used to play with dominoes, but I didn't play dominoes. I just stacked them up and knocked them down, okay? This was before the age of the internet. So if you stack dominoes, and this is a top view, you're looking down on them, right? Lining them up straight gets boring after a while. Then you figure out that you can change direction, but you can't do it like this. Right? You can't just take one domino, rotate it 90 degrees, and it's going to go off to the side, right? You learn through trial and error that you have to gradually, you got to do a little bit here, a little bit there, a little bit here, a little bit. Next thing you know, you're off and running. Right? So the point is, when we look at articulations, specifically only two bones that articulate, in other words, C3 and C4, and we only look there, that's not a significant motion. More than none, less than most. However, when we put the whole thing together, like the whole slinky, the sum total of all the little bits, then we get significance. And I can't say that my neck doesn't supply significant motion and move it all like this. But the key thing is that for me to call it significant, I have to have the sum total of several little bits. It's the change. Each day is insignificant, but a whole year's worth is very significant. Make sense? So the first subclassification of the significant movable joints. First of all, the category we call diarthritic or diarthrodial joints. That's the ones that allow significant functional movement. But the first subclassification of significance is a term we call arthrodial, meaning it's the sum total of a bunch of little bits. It's when we look at the dominoes, not one domino about the other, but several dominoes all chipping in together to create significance. So I can have significant motions at my spine, but it takes the sum total of all of those little bits to create that significance. A few examples of this is in your foot, underneath your talus, your subtalar and transverse dorsal joints. I know that's a lot of syllables, but basically what lives under your ankle are a bunch of dorsal bones that can glide and shift in your metatarsals. And when they summate all of their little bits, that's actually what creates this significant motion side to side. It's the sum total of a bunch of little bits. Okay? Now, I like to use slinkies for the spine because you can visualize a slinky and how it can bend forward and to the side. So, diarthrodial joints, the most movable articulations, they are subclassified based on how many planes they allow motion in. Now, that's not a global reference, it's a local reference, because my elbow only allows motion in one plane, but obviously I can move it in 3 of the room's planes. If it was a global reference, every joint would be what we call triaxial. So joints, in terms of the most movable, are subcategorized by their movement possibilities. Arthrodial being the first one that's kind of weird. Because it's the sum total of a bunch, we acknowledge that the summation of all of those things can move in all three planes, potentially, like the spine, can summate sagittally, summate frontally, summate transversely. However, because there's not one true fixed point, in other words, it's several bunch of little axes. There's not one true axis. Like if you talk about moving your elbow, there's like one point about which that elbow is moving. So because there's kind of that technicality of being several little axes, that's why in your text they refer to it as non-axial, because the amphiarthrodic little bits aren't enough to coin rotation about an axis, because it's just a little bit. So although the summation can occur in different planes, we don't say it's axial because there's not one point about which all that rotation is occurring. It's kind of a technicality. Okay? Now getting to the easier ones. Joints can be classified in terms of the diarthrotic, the movable, uniaxial, biaxial, triaxial. We did this exercise last week. If something can rotate in one dimension, how many different ways can it spin? Clockwise, counterclockwise, right? So if a joint is uniaxial, that means it can spin about one axis, either an AP, a bilateral, or a polar. So that means that joint, we're going to have to account for two different joint motions, whether it's flexion, extension, pronation, supination. So if a joint is biaxial, that means it can move about two different axes. It can rotate in two of its planes. We got to account for four motions. Right? And then triaxial, that's our ball and sockets. And we're going to have to account for 6 motions. Should make sense. And of course, there are some sub-classifications, because everything in life is a continuum. And so there's like, well, these are both uni, but one is in the transverse. So I'm going to explain all that stuff. Okay? So let's get to the most common uniaxial joints. We're going to work our way to the most complex, and that is our hinge joint. Hinge is kind of the layman's terms for it. It's kind of the layman's terms for it, but the Latin term is ginglinus. So I'm going to go with hinge. Okay? A hinge joint, just like the hinge on a door, that door can move in one plane, 2 different directions, open, close, open, close. So we have hinge joints that are the same way. They are only allowed to move in one of their planes. Examples of hinge joints in the body, our ankle joint, our true ankle joint is a hinge. I'm going to teach you that this is in a different place than this. So our true ankle joint, there's our axis, those malleoli, those ankle knots. There's your bilateral axis. And the talus does this, just like a hinge. Okay. All of this stuff is happening underneath. Submarine under the water, subtalar under the talus. Subtalar joints. Other example of hinges, your elbow is a hinge. The stuff you do here isn't at your elbow. It's your radius wrapping and unwrapping. So your elbow can only do this. It's like a door. Except we can move the door. Okay? Your interphalangeals are hinges. Distals and proximals. Most of your fingers. Your knuckles are different because your knuckles can move in a different dimension than your interphalangeals. Okay? So those are just some examples of hinges. The one, I say it's not a separate thing, but a subclassification of a hinge is our knees. Our knees are modified hinges, specialties. Guys, think of it in sports. Don't you have a lot of specialists in different sports? Like, so what I mean by that is maybe in football, you can have like a traditional linebacker, but if you need someone who might need to cover or do something, you can have like a linebacker who's a little smaller, maybe a little faster to serve a certain specialty niche. And so our knees, because of the cut and plant mechanism we need to run away from danger and to move and to play, if our knees weren't allowed to give a little bit in the transverse plane, we would rip our knees up even more than what we do. In other words, when we cut and plant, there's torsion, twisting forces happening there. And we have to give a little bit at the knee in order to dissipate that force. Okay? We don't need to do that on our elbows. So the knee, we call it a modified hinge. It's mostly a hinge, right? It does the same things, except the knee can rotate when it's flexed. I'm going to get into the whys, but I'll just explain to you that there's these differences in some of the joints that we think are the same. That's all. Similar, but different. So, you know what's really cool? On the test, I've been known to ask a tricky question like this. Which category of joint is more like the elbow? And I'll put like the knee or the ankle. Well, the ankle is a hinge. The knee is a modified hinge. Which one is more like the elbow in classification? The ankle. Yeah. Bless you. Okay? So, hinges. In addition, we have recall. I know it's hard to recall sometimes at 7:30 in the morning. But I talked about pure rotation and then these combinations of things. The examples I gave you is which one looks different? Apple, banana, strawberry, sledgehammer. Use a sledgehammer. Which one looks different? This shoulder motion, or this shoulder motion? You know? The last one, right? So we have a classification of diarthrodial joints that's uniaxial. However, it's specifically about the polar axis where it's more pure rotation. Atlas axis at the head is an example. A specialized joint that kind of gives a little bit more transverse rotation before you start sub-8ing all the other. Radial ulnar joint is a specialized uniaxial joint. What do we call that joint? We call it a pivot joint. Pivot joint. Or the Latin term is trochoid. But we're going to call it a pivot in this class. Pivot joints. So the point is that the radial ulnar joint can only move in two different directions about one axis in one plane. So can the elbow, but look at the difference. It looks differently when it's pure rotation, right? When the center of mass isn't going anywhere. And that's why it has a different classification. Because it's about the long axis. It's like spinning a merry-go-round. Okay? Biaxial joints. I'm only going to give you two. The wrist is a biaxial joint. What that means is that in anatomical position, it can go sagittal road or it can go frontal road. It can't go transverse road. This is not at the wrist, that's at the radial ulnar joint. Here's one way to show you that the wrist doesn't move in the transverse plane. Take your right or left hand, brace it up against your body, and you can passively move it sagittal, you can passively, but you can't twist it some of the time. In other words, if you start to twist it, your forearm starts to move, because that's where the articulation is. Your wrist doesn't twist. It can go sagittal, it can go frontal, but it can't go transverse. If your wrist goes in the transverse plane, we need help. Either a paramedic or a priest. Or both. Helps if there's both. So the wrist is a biaxial joint. We call it an ellipsoid joint. It's a classification you have to know. Biaxial. What should we automatically know about biaxial joints? 2 planes, 4 motions. And the sagittal is going to be fetal out of fetal, and then I'm going to teach you what the frontal one is. But for the first test, it's just about classifications. It's just this type of joint moves how many ways? Not how they move, right? I'm not going to ask you about flexion, extension, abduction, specifically what I'm talking about, articulation of joints. But you got to know how many ways can it move. Hinge joints can move 2 ways. Ellipsoid joints can move 4 ways. That kind of stuff. Knuckles are a little different. Knuckles are very similar to wrists, but unlike the wrist that splits itself from transverse motion, your knuckle actually can kind of twist in the transverse plane, allows some passive rotation. You can't actively twist it, but because we're trying to contour around things, it allows more passive rotation, so they give it a subcategory called a condyloidal joint. All right, the last one I'm going to get to, I'll talk about the thumb a little bit, but your ball and sockets, your shoulders and your hips. Triaxial, so how many motions are we going to have to account for? 6. On the test, you're going to have to know the sagittal plane one, the one that gets you into a ball and out of a ball. On your second test, we're going to get into the more specifics and the illusion stuff. Triaxial, ball and sockets, they can move about 3 axes, they can move in 3 planes, so I got to account for 6 main motions. They can go sagittal, they can go frontal, they can go transverse. Okay? Obviously, we don't move in robot world. What I mean by that is, even though we're talking about sagittal frontal, it's like this. But I want to make it clear how easy it is to still see the sagittal frontal and the transverse, the bulk, the main planes. How many of you ever played with an Etch-a-Sketch, right? You have an Etch-a-Sketch and they have 2 knobs. One knob makes the little magnet go up and down, the other knob makes it go left, right? Well, if you only move one knob, you're going to see a straight line kind of motion. You move the other knob. But what happens when you move both knobs at the same time? You get some combinational stuff. So what I'm trying to get to is that when I move this knob and that knob, when I twist both knobs at the same time, that's when you get this kind of stuff. This is made up of some of this and some of that happening at the same time. That's all it is. It's not a different dimension. There's no third knob on the Etch-a-Sketch. It's just a combination of those 2 main knobs. So a combination of sagittal and frontal gets you here. Some of it here, some of it there. Peanut butter, chip. Okay. Most motions happen in all 3 planes. So what we have to do is we have to extract what's happening transversely, what's happening sagittally, what's happening frontally, eventually so that we can identify muscles that pull in those specific directions. In other words, if I was a puppet, if I was activating a puppet, and I had some strings that pulled this way, and I had some strings that pull that way, I don't have to have a string that pulls here. If I pull on the front and the side together, they're going to cancel each other out and move the arm to the side. So we're going to have to be able to see the sagittal component would be these, and then the frontal component would be those, and they work together to make it go in a combination. North, south, east, west, northeast, south, that kind of stuff. Okay? All right? The thumb. Ooh. This one's a little debated. There's a lot of debates on a lot of different things. But the thumb is, man, so cool. It's called a saddle joint. And it's a very specialized articulation, very unique to us humans. And the concept is actually pretty cool and pretty simple. Imagine if you had, one time I tried to draw, do you want to see me try to draw a horse? Do you want to see it? Oh, Lord. Okay, here we go. Campbell's horse. Oh, gosh. Why does he have a square? Oh, my gosh, it's pregnant. Let's see. Oh, where's his other foot? Oh, that didn't turn out well. I'm going to take him down to the road. I'm going to fly till he can't no more. That's a wolf. Okay. That's a wolf. All right, so like I said, I was going to draw a wolf. And if this is so bad, dude, am I even trying? That's a tail. That wolf is embarrassed. He's like, oh my God, I can't believe you created it. Okay, imagine this was the sway back of a horse. If you put a saddle on the horse, now I know a saddle, you strap it in, it's not supposed to go anywhere, but what if it did? The saddle could rotate about the horse like this, right? Now, it's not going to happen on a real horse, but technically I could take the saddle and move it like this about the horse. I can't really do that. That's what your thumb is. Your first carpal metacarpal joint has a very unique articulation that mimics your first carpal has the kind of sway back, and then your first metacarpal has like the saddle. And it does like this. Now, where the third dimension kind of gets, there's debate, is that what we see is we see this plus this can give you, it can create this illusion. Circumduction is a term that's used a lot as a separate joint motion, but it's actually a pattern. It's a combination of our three main dimensions. So in other words, I can do this, but that is actually just a combination of this and this when I move the Etch-a-Sketch in curves. Your Etch-a-Sketch doesn't have a curve knob. It has an up, down, and left, right, and when I move them together, I can make circles. Okay? So that's how your thumb works. Your thumb works kind of like a saddle in its articulation. That's super duper 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 cool. Okay? Let me see where we are. All right. Any questions, clarifications on joints, articulations? You're going to need to know the basics of what I taught you today, and that is categories. Boom, boom, boom. And that's appropriate because my attempt at drawing a horse was very sad. You're going to have to know the categories. You're going to have to know the subcategories. And more than anything else, motions that these joints would allow for. Okay? Because when we get into the specific joints, I'm going to be like, this is a modified hinge. This is a hinge. This is a pivot. This is an arthrodial gliding. So it's important to kind of get that into your head so that way when we get on to the second test, it's just, oh, okay, yeah, that's two planes of motion. You need to account for four motions. Okay. All right, let's practice some planes and axes. What if I did this and I said local reference? So right away you should know perspective, right? If I say local reference, the person who is moving. What if I did this? How do I see this rotation? Let's see. We got transverse, frontal, sagittal. Was that rotation in my transverse, my frontal, or my sagittal? What you got? Transverse? Yeah, my transverse. What did the room see? Room saw frontal. What did the front of class see? I didn't mean to put you on the spot. You just happen to be in the front of class. You're the center of mass of this classroom, so you speak for everyone. I'm joking. You don't have to answer. I'm just kidding. The room sees frontal, right? The rooms. Remember how I drew the eyes on the board, and I said when I say global reference, what does the room see? So wouldn't the room see the spin, kind of like how a clock would spin? Right? Now, very specific. Left side of the class. You guys are kind of at an angle. Left side of class. How would you see the spin? You would see the spin in your sagittal, right? Does that make sense? And so notice I am never, ever going to not give you a perspective on the test. I have to. So that way you can answer it. The one exception is if I'm in anatomical position and everybody sees the same thing. then it's irrelevant. In other words, if I say, I'm here and I do this, I don't need to tell you the perspective because the room and I see the same thing. That's the one exception, is when everybody has the same answer. Cool? Okay? Let's go axis. Global reference. Where's the spin happening? About what axes? Polar. How about now? Room's perspective, what axis? Bilateral. Room's perspective, what axis? Anterior, posterior. From my joint's perspective, this is the same thing as this, is the same thing as this. And that's why when I'm going to teach you pronation and supination, that's why it doesn't change regardless of if you hear, here, or here. Because it's a locally referenced concept. To that joint, it's either doing this or this. It doesn't care about what the room is doing. It just cares about what it's doing. Okay. All right, one more. What plane would the chair be moving in? Let's see if I did like A, B, C, D. So A is transverse, B is frontal, C is sagittal, and D is none of these. What do you think? None of these. For it to be a plane, there has to be spin. Now, it's moving, but it's moving in a straight line, right? That's when we would say it's moving in the negative X. Or it's moving to my right, to your left, it's moving east, it's moving west. That's how we describe straight line motion. If I did this, man, y'all bad today. I've had enough of y'all. Y'all get out of here. It's okay, I didn't pay for it. Now I can talk about, did y'all like that they'll come out in a minute? That's how we talk when we get upset. Me. Now I can communicate. Yeah, the chair might have still moved to my right, but that's a straight line conversation. In terms of the rotational component of that general motion, frontal plane, from the room's perspective, right? And based on how I saw it, if I was here, that would have been my sagittal. Another tip I want to give you guys is if you can see spin like when I did this kind of stuff, where are all my CDs? There it is. So in other words, if you get this, if you're like, I see frontal, it's all good, I see transverse, I see sagittal, you can literally create that in the joints. What I mean by that is, if I'm moving my elbow, and you're like, I don't see it as well as I see, then you can just imagine, what if the elbow just kept spinning? Right? It's the same road. What if I do this to this, and you say, well, what if it just kept going like this? What if it just kept going? So I don't mean for you guys, but look, first of all, if it means getting the right answers, I'll do whatever it takes. So I'm saying, like, nobody's going to judge you if it makes it look like you're casting a Harry Potter spell. Man, nobody cares. Right answers, man. So if I'm doing something and you're like, I'm not quite sure, then just imagine, right? How would it keep spinning? It's just maybe a tool that may help. Another thing I would suggest, since we're getting close to our first test, small groups. Studying in small groups is so beneficial. And listen, that may not be your thing. I get it. But the positive about studying in small groups is you can come up with different examples. You can help each other by coming up with different analogies. Because if all you ever do is answer your analogies, my questions may be outside of your analogy box. So getting other people to say, oh, I was doing something the other day while I was practicing, that's great practice. The best way to learn a foreign language is to speak that language with someone, is to practice it, is to do it. Okay? So that's a big help. Also, when you're in the weight room or when you're exercising, practice. Heck, when you leave class, practice. My knees are rotating in what plane? And if I look this way, I'll meet you in the parking lot. But if you're at home, if you're in the weight room and doing things, take note of what plane you would be in the way you see it. And listen, any room can have a global reference. All you got to do is say, where do I want to call the front and the back of room? So therefore, those are the sides, and therefore those are up and down. So any room can be made into a globally referenced room. Any questions? If you do have questions and you're kind of shy to ask, I get it. In the back of your book, there are some feedback sheets. And the feedback sheets are meant for you to say, oh, dude, you really went fast right here. I didn't quite get this part. Or can you give me more examples of this? And look, it can be anonymous. But you write in your questions that maybe you don't want to ask out loud and leave it up here face down. And I'll look at it. I might lead off class with it. The next day, I may make a secondary video to answer them for you. Or if you want me to contact you, leave your name, I'll email you and answer your question. Okay, guys? All right, have a good hump day.